I forgot my mask just now. So I went back to my car to get the mask. Okay. Today we will learn derivatives. Derivatives. This section 2.1, there are two main objects. One is the slope or slope of tangents. Suppose we have a function f, real value. F is defined as A. Suppose the graph of the function f is this curve, and A here. Then the point P here, whose coordinates are A, f of A. If the curve is smooth means if we zoom this part, maybe looks like suppose we zoom this part. Suppose we zoom this part. Suppose we zoom this part. Okay. So smooth means locally it's linear. Locally linear. Okay, we zoom. Then locally linear, so this one almost a straight line, almost a straight line. Can you give the equation of this straight line? Yes, we may choose. Well, this point is P. We may choose some point nearby A. Yes, very close to A. X is. We have some point Q. Suppose X is sufficient close A, then Q may be here. Maybe here. Okay. Suppose these 2 points are in a straight line, then the slope of this straight line will be why we need secant here? Because if a straight line passes through this 2 points, this is a secant line to this curve. Just like we say for a given circle and the points on this circle. This straight line intersects this circle at 2 points. We call this one the secant. If a straight line intersects this circle at exactly 1 point, then this is tangent or tangent line. Secant line, tangent line. This is a circle. Okay. So in order to find this one, we may zoom this part, and finally, if x sufficiently close to a, then the slope of this one should be the slope of this straight line. Suppose we are an insect or very small creature, and close to this part. Then what do we take a look or see? The view will be here, and here. So when x close to a, equivalently we zoom, and what do we see? Will from this curve gradually flat. Okay, gradually. Then this line, if this is a straight line, here is a straight line. If we observe this part close enough, but in the original position, that line will be tangent to this curve. Will be a tangent to this curve. Okay, so if we choose some points nearby A, then for example here, and here, then or here, then the tangent will change from this one to this one, then this one. This tangent rotate. Finally, the limit position will be this tangent. Okay. So try to image. Come close to A, moving toward to this position, then this secant. The limited position, this one, quite similar to this one. So tangent, if the curve is smooth means locally linear. Locally linear means if it's some neighborhood of A. If this diameter is small enough, then the portion of this arc approximately exactly a straight line. Okay. So if x close A, but different from A, close enough, then this one tangent. Okay. Another expression, alternatively, we may express this by L of x minus L of a over x minus a, and then take limit. Suppose this limit exists, then we say this number is the slope of the tangent. So the tangent is defined to be or tangent line is defined to be this curve y equals FA plus the slope is m. Okay, where m is defined to be this number. That this means for given function f at the neighborhood of a, if this limit exists, we say this limit is the slope of the tangent or tangent line to the curve at a slope. So tangent line is by observation and use a ruler to sketch a straight line. This is not math. We can find this by using subtraction, division, and limit. Okay. Okay. Got it? Understand? So this generalizes what the tangent, the notion, old one for circles to the curves, to curves. Well, this is the notion, the motivation of this one. Okay, so this number is exactly the slope of the straight line PQ. The slope of this one, PQ, of this one. But the limit will be a number. We define this number to be the slope of some straight line passing through this point. That straight line is called tangent. It's called the tangent to this curve. Okay. So, reference quotient. We call this form a difference quotient, or Newton's difference quotient. Newton, the physicist Newton. Okay. Well, this is the first notion, tangent or slope. The second notion, or the second concept, is velocity. Suppose now there is a particle or an object moving along a straight line, for example, at time t. Whose position is f of t? At time t plus delta t, or t plus h, maybe here. Position here. So we have a clock, and also maybe a car moving. Okay. We are interested in how fast this particle moves. How fast. So we can find the displacement. This is the origin. This is a position vector f t. This is another position vector at time t plus h. So the displacement is f of t plus h minus f of t. So this is the displacement. We can find this displacement by using subtraction. This is the displacement. If this one is smaller than this one, then displacement will be point to the left, which is negative. In this case, this vector points to the right, so this is a positive number. Okay. And the time traveled will be t plus h minus t. Time. And again, this number is called the average velocity of the particle. Okay. On this time interval, t to t plus h, or from t to t plus h. The average velocity. Of course, if you consider the h very small, sometimes this limit exists. The limit, this is h, not t. The difference of these two numbers is h. Suppose this limit exists, then we define this is at v of a. We call this velocity here of this particle at time, t. This time this is t, or instantaneous. Instantaneous velocity at time t. So sometimes a ratio or a quotient of two difference is important for application, application. And there are many other, for example, in economy, marginal cost, marginal revenue, marginal profit, and so on. And Anyway, this one is this expression is important from on many areas. So we are abstract. Then, in terms of math, suppose we have the real valued function f and this is x. This is x plus h. Then this one we will okay. A given function may be the dependent variable. We use y, and we use x to be the independent variable. Then we give some terminologies, delta x, which is defined to be x plus h minus h is the change in x, or change of x, or the increment of x. And delta y is defined to be f of x plus h minus f of x. The change in y, or the increment of y. This quantity is called the average rate, because delta y, delta x is exactly the quotient of these two numbers. So we say rate of change. Rate of change. The average rate of change of the variable y with respect to x. The rate of change of the variable y with respect to the variable x. Finally, if we take limit, or equivalently and if this one exists, then we use this notation. This number, if it exists, is related to this function f and related to this number x. So we maybe the simplest way to define this one is use some line. This one is displacement. H. No. Time. The difference of time. Time, I don't know, maybe travel, or I don't know how to, E or A. E, okay, time travel. That is where the particle from here to here use total time. The amount of time is t plus h minus t. Oh, here.
X plus h minus x.
F of x plus h minus f of x.
Delta x.
Mm-hmm. Oh. Oh, delta. Oh, yes, yes, yes. Thank you. This should be x. Means this one change in x. This is change in y. Change in y. Thanks. So we abstraction. From some examples, we know the main part is to find this one difference. This one also difference. This one difference quotient and limit. The number of derived in this way, we give it a name. Derived in this way, then we use this derivative. Of the function f at the number a. Derived. By using this process, we call derivative of f of x. Okay, we use this name terminology. 好，所以我们在这里知道了，讲到一个函数图形的时候，我们想要看看它的切线。什么是切线呢？就是把那个图形局部放大，再放大，就是变成一直线的情形，这个叫平滑的。可以考虑割线，可是在平常地方看就是弯曲的，所以那个直线其实就是心目中的切线。我们可以考虑割线的斜率的极限，叫做切线的斜率。讲到指点运动的时候呢，我们可以考虑什么呢？可以考虑在某个时刻到时刻之间这个时间区间，指点从这个位置到这个位置的位移或位置这个变量对时间这个变量的变化率，叫做平均速度，取极限叫瞬时速度。其实，在自然科学还有许多地方都有这样的类似的东西，考虑变化率。因此，我们把它抽象化 ，abstraction， 在数据上我们可以考虑任何一个单变数值的函数，考虑 x 的改变、y 的改变或 x 的增量、y 的增量，以及平均变化率，取极限叫瞬时变化率。这个出来的数字呢，显然跟 f 有关，也跟 x 有关。我们随便选一个符号，打一撇也可以，打一点也可以，打个帽子都可以啊，称为函数 f 在 x 的导数，因为是用这个方式推导出来的一个量，也不用在那个用什么新的字了，就 derive 是推导 ，derivative 就叫导数。Okay, so this is the notion of the derivative. So there are some equivalent terminologies for a function of one variable.